This here is a 5.5 watt Osram LED bulb. It's a bayonet style bulb and it's been in service for a couple of years now. It's been on an automated timer that goes on every night for a couple hours, and unfortunately it no longer works, so I thought I'd try and fix it. So as is usual with LED bulbs, the diffuser is made of plastic, so I think I can just lever it off like this. And after doing that for a while, it came loose like this, and we can see the diffuser is adhesived in with what looks like silicone on these tabs here, and the diffuser is indeed made of plastic as it's all bendy. Now looking at this aluminium core PCB, we can see there's 8 LEDs on board, and if we look closely at them we can see that there's 3 pieces of silicon in each chip. So these are probably 9 and a bit forward voltage LEDs, which allows them to use so few LED packages in probably what operates at a reasonably high voltage. And we can see that these LEDs are connected to rather large copper areas on the PCB, which presumably helps with heat dissipation, although interestingly they don't use the same side of the LED package. So I'd imagine some of these would fail before the others, but let's test them to see whether or not they're good. They don't have the black spot of death on them, so I think they might be good. And testing this first one, it's probably around the wrong way. This one's good. Yep. Nice warm white. This one's good. This one's good. 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 And round the other way, this one's good, this one's good, and this one's good, so they're all good. So it's probably a problem with the power supply, so let me get this silicone out of the way. And I'm not quite sure how to get this aluminium board out. It's really wedged in there. They seem to have press fit it into the aluminium case of the LED thing. Yeah, so this thing was pretty difficult to get out, so I fast forwarded it here, and I ended up having to just stuff a metal spudger in the side and lever it out, which actually broke the outer plastic bit, but I was just able to superglue that back together. And of course the bayonet style contacts on the bottom, we can just lever these out. They're just press fit. Sometimes they're soldered. So now that we've got the power supply out, the first thing that we can see is that it's rather discolored. So this thing certainly gets very hot during operation, which is no surprise seeing as it's a dirt cheap product. But there's no obvious skid marks, nothing's catastrophically exploded. Everything looks reasonably good. No broken solder joints that I can immediately see. On the other side there's some pretty basic components. Here we see the capacitor is actually 125 degrees rated, so that's good. No bulging. The capacitor is an Aishi brand, which is pretty good actually. This inductor is marked 4.0 brackets 0.6, so I imagine that's probably 4 microhenries at 600 milliamps. That seems a bit much, but it's probably correct. So I think the very first thing to do will be to test this here fusible resistor, just to make sure it has continuity, and testing it. Yep, it has continuity. It's a couple of ohms. So I'd say this is good, and that means something hasn't catastrophically failed short circuit. Now testing this diode bridge, we expect to see some diode drops in some directions and in other directions not, so testing that, there's a diode drop and a diode drop, and the other way round, from the negative side, diode drop, yep. Now the next thing in the circuit before that large bulk 400 volt capacitor is this here inductor, which probably has something to do with the power factor, and measuring that for continuity, pretty sure I've got a good contact here, but it's measuring like millions of ohms. Yeah, I'm definitely making good contact, so I think this inductor might be bad. Now, looking at the inductor, we can actually see that there's some cracking on the top here. So I'd imagine this thing has been thermal cycled a few too many times, and something inside of it has gone wrong, or maybe it's just underrated and something has melted inside. And we can also see on the bottom here there's some more cracking. So yeah, this inductor isn't happy. So I'm just going to remove that. Now the color code on this inductor says it's a 3 millihenry inductor that's 10% rated. I had to look through my junk box and I couldn't find a similar thing, although I had this larger 10 millihenry inductor, and it's physically larger as well, so I reckon that'll do. I don't really know what this thing's rated for in terms of current, but I imagine it's probably good enough for this application. And just putting that back in place, soldering it together, and then putting this thing back together. Not too difficult. And then I put it back in the fixture and turned it on, and we can see it works perfectly now. So that inductor was definitely faulty. And I also had a look at it with the thermal camera, and it didn't look too bad. I mean, it gets pretty hot, but I imagine it's designed like that. So I just put the diffuser back on, and it should be good to go. Now, this inductor here that's failed, I'm actually quite interested to see how it's failed. I'm not sure if some of the windings have overheated and fused together or something, and it's, I don't know, exploded inside maybe, or if it's just a thermal cycle thing and some of the wires have broken or something. So I think it's a good opportunity to do some more advanced failure analysis on this. So I'm going to prepare some 2-part epoxy here, and I'm just going to mix that together, mix it, and then of course once I think I've mixed it, I mix it some more, otherwise it turns out rubbish. And then putting the inductor in and mixing it around to make sure all of these surfaces are wetted. And then I put that on a little hot plate I made for a couple hours, and here I'm just going to crank it up to max. Alright, it's been about 3 hours, and I've let this thing bake for a while as well as cool down. And in hindsight, I think I roasted it a little bit too much, as it's formed quite a few bubbles and has discolored a little bit. However, that doesn't really matter in this application. We can also see actually that there's some bubbles that have formed around the cracks, so yeah, I wonder if some of the epoxy's gone in there and some of the air has escaped, and that's where some of these bubbles are coming from as well. Now, to start off, I'm just going to use some 220 grit sandpaper, and I'm just going to go to town on it. And I'm going to get through the first layer, and here we can start to see some of the construction of it. Looks to be a whole heap of fine wire wound around a ferrite core. Now that we've got more of it off, we can start to see some more detail in how this thing's manufactured. Can't see any obvious melted sections, it all looks pretty good. Now I'm going to grind it down to the very center so that we can have a look at how this thing has its leads constructed, because I'm not actually sure how they put the leads in this thing. And now I'm at about the center, so I'm going to go to 2000 grit paper and wet sand it. And then go to 3000 and sort of polish it. So now it's nice and polished, we can take a look at it, and ooh yeah. So this is how they do it. So it looks like they wrap the wires around the lead here and solder it together. And then they sort of glue the lead into the end, and the end of it has been formed. And we can see the interface here between the ferrite and the lead. And we can also see right here where that crack is. And we can see on the outside of the device as well where that crack was. So it looks like that crack has formed around where the wire comes off the lead and goes around to the actual windings. So I suspect one of these cracks has broken that wire, and that's why it's gone open circuit. So that pretty much solves the mystery as to why this thing's broken. Unfortunately, I didn't get a smoking gun picture of exactly where it's cracked, but I think that shows pretty much where it's happened. So I'll just leave you with some nice pictures of that cross section. So, as always, thanks for watching.